Hello, welcome to this video. Today we're going to do this problem. So the question is, for what n, it's a natural number, is 4n to the fourth minus n squared plus 4 prime? So let's see. First of all, in all of these prime number questions and when is this thing prime, you usually want to factor the number to show that in almost all cases it is not prime because it is a product of two numbers that are bigger than 1. And then you look at the specific case of when one of the terms is 1. Okay, so now let's do that here. So a good way of factoring in these prime number questions is what you usually do, because you have all these pluses and minuses. What you usually do is try to get to a point where you have a square number minus a square number, because then you can use the difference of squares formula and get to a product. So that's what we're going to try to do here. So let's see. 4n to the fourth minus n squared plus 4. And you can see it's very close to something squared. If we just change this minus to plus and put an 8 in front of this n squared, we can now see that this is 2n squared plus 2 all squared. And that's because of the formula of a sum squared. A plus b squared is a squared plus 2ab plus b squared. And that's what this is. A is 2n squared, b is 2. And then when putting that in, you can see that this is true. But this is not our statement, and our life isn't that easy. So what we need to do is to see how we can get from this to our original statement. Well, all we did was change this minus to a plus 8 times this n squared. So we just need to subtract 9n squared, and we're back where we started. So we get that 4n to the fourth minus n squared plus 4 is this expression, 2n squared plus 2 all squared minus 9n squared, to account for this minus changing to a plus 8 times. Okay, so this is minus 9n squared, and so this is minus 9n squared, and as it turns out, you can easily see that 9n squared is itself a square number. This is actually 3n all squared. And that means that now we have our difference of squares, and now we can use the difference of squares formula to get that this is 2n squared plus 3n plus 2 times 2n squared minus 3n plus 2. Now we have a product. And now that means that this number is never prime as long as both of these are bigger than 1. N is a natural number, so this is clearly always bigger than 1, which means that the only case we can have for one of these being equal to 1 is this. So now let's see if we have an n. It's a natural number and makes this expression equal 1 and makes this number be a prime number. So we actually have an example. Because if this being 1 doesn't change, if that this could be something like 6, then we don't have a prime number. So let's do that. Now, 2n squared minus 3n plus 2, we want this to equal to 1. Now we simply subtract 1 from both sides. This becomes a 0, this 1 becomes a 0, and this 2 becomes a 1. Now we can factor this to get that this is 2n minus 1 times n minus 1. Meaning that one of these is 0, because the product is 0. If n minus 1 is 0, then n is equal to 1. If 2n minus 1 is 0, then n is equal to a half. N is a natural number, so this option is ruled out, meaning that only when n is equal to 1 does this expression equal 1. Now, we just need to check that this turns into a prime number when we substitute n is equal to 1. Because then we have a prime number times 1, which gives us one example for n is equal to 1, which is a prime number. But let's not get ahead of ourselves, let's check. So, 2n squared plus 3n plus 2, n is equal to 1. It doesn't get any simpler than this. 1 squared is also 1, so 2 times n squared is 2, n is 1, so 3n is 3, and then plus the 2 at the end. This obviously gets a 7, which is prime. That means that for n is equal to 1, this is 1, this is a prime number, the product is a prime number. And for all other n, both of these are bigger than 1, meaning that their product cannot be a prime number. So finally, we have our solution. Only n is equal to 1. And then this expression is equal to 7. For all other cases, it's something bigger than 1 times something bigger than 1. And finally, that's it. If you want more content like this, please subscribe to my channel. I'll be uploading more interesting problems like this in the future. And finally, that's it.